Okay, so I just wanted to go over one more question like this because this one looks like a little bit more difficult because there are two different denominators instead of just one like the other examples. So again, I'm going to go over it both ways. So the first way again is using division. So I'm going to just rewrite this as 4 over x squared plus 2 over x plus 4 divided by 2 over x plus 4. Okay, so we're going to look at this first parenthesis, and we want to get a common denominator. So the x squared here is missing an x plus 4, and this x plus 4 is missing an x squared. So I'm going to multiply the first fraction by x plus 4 on the top and the bottom. So this becomes 4x plus 16 over x squared times x plus 4. And then the 2 over x plus 4, that's missing an x squared. So we need to multiply the top and the bottom of this fraction by x squared. So this becomes 2x squared over x squared times x plus 4. So now that the denominators are the same, I can add the numerators together. So I'm going to make this 2x squared plus 4x plus 16 over x squared times x plus 4 divided by, and this 2 over x plus 4, there's nothing else going on here, so I can just leave that as 2 over x plus 4. So I have division, so I'm going to change it to multiplication. So I'm going to have 2x squared plus 4x plus 16 over x squared plus x squared times x plus 4. So I stayed, and I'm going to switch my sign or my operation from division to multiplication, and then I'm going to flip the second fraction. So this becomes x plus 4 over 2. Now we want to see if we can factor anything. So if I take this top one and I factor out a 2, I have x squared plus 2x plus 8. And then the bottom is the x squared times x plus 4. And then I'm going to just keep this as x plus 4 up here over 2. So the x squared plus 2x plus 8, I can't factor that part any further. If I try to factor it, what multiplies to 8 that adds to 2, nothing's going to work because 4 times 2 is 8, but they're both positive and they can't add to 2, and I can't have one negative and one positive. So that doesn't factor anymore. So now we can try to cancel things out. So this x plus 4 and this x plus 4 will divide out. This 2 and this 2 will also divide out. So we end up with x squared plus 2x plus 8 over x squared times x plus 4. Oops, we cross that out, so no, we don't. Over x squared. And then be careful, you can't cancel out the x squared on the top and the bottom because the x squared is attached to other things on the top. So we can't just cancel anything out. So this would be our answer. And then we have our domain restrictions to think about. So again, we had division. So we're going to take the bottom of the first and top and bottom of the second and set them to 0. So if you take the bottom of the first, you have x squared. So if you set that to 0, you get 0. If you have x plus 4 and set it to 0, you get negative 4. The top, x plus 4, you're also going to get negative 4. And then 2 that's on the bottom, you can't set a constant to 0. So these are our only restrictions. So it gets a little bit more complicated the more complicated the fractions get. But here we end up with our answer. So we're going to do the same problem again, and we're going to do this with the LCD method to see how simpler that one can be, and get the same answer. Okay, so if we look at this problem, again, same problem. We're going to do this the LCD way. So first step is, what is the LCD? So you're going to look at all of your denominators. We have x squared, x plus 4, and x plus 4. So what the common denominator should be for all of those would be x squared times x plus 4. So what I'm going to do with that LCD is I'm going to multiply x squared times x plus 4 on the top and the bottom of this. So again, by multiplying by x squared over x squared times x plus 4 over x squared times x plus 4, this is really like multiplying by 1, so I'm not changing the problem at all. I'm going to take each of these and I'm going to multiply it to the top. So first let's look at the 4 over x squared. So 4 over x squared times x squared x plus 4. So we're looking for things that cancel out. So if I multiply 4 times this and then x squared's on the bottom, this x squared and this x squared are going to cancel out. So all I have is a 4 times an x plus 4. So that's going to give me 4x plus 16. Then I'm going to take this second fraction, the 2 over x plus 4, and I'm going to multiply it to the x squared plus x squared times x plus 4. Same way I did the other one. So the x squared times x plus 4, this is really only getting multiplied to the 2. So the x plus 4 in the bottom and this x plus 4 are going to cancel out. So then we have 2x squared. So that is the top. And now on the bottom, I'm going to take the 2 over x plus 4 and multiply it by the x squared times x plus 4. Again, this is getting multiplied to just the top. So the x plus 4 in the bottom will cancel with the x plus 4 in the top, and we'll be left with 2x squared on the bottom. So once we get to something like this, again, we've knocked out all of the steps in between. So if we go back to our division one, we had all of these other steps in between. Here, we go right from our LCD to our almost final answer. So once we get to here, we wanted to simplify this. So I'll just write it in standard form in case we could factor it, but we know from the previous problem we can't. But write it in standard form, and then I'm going to factor it. So when I'm factoring, I'm always looking for GCF first. So I'm going to take out a 2. So I have x squared plus 2x plus 8. And on the bottom, I have 2x squared. I have the x squared plus 2x plus 8. I cannot factor it anymore, like we said in the previous slide. So this 2 on the outside and this 2 on the bottom, I can divide out. And I end up with my final answer of x squared plus 2x plus 8 over x squared, which again is the same answer I had in the other slide. Show it again, same thing. And then for our restrictions, you're going to take the LCD and set it to 0. So you get 0 and negative 4. And then you take the denominator of your simplified answer. So the 2x squared, set it to 0, which you get 0 again. So we have the same exact restrictions, which we should have, which is 0 and negative 4. Okay, so it's really up to you which method you decide you want to use. This one is a lot faster, as long as you understand what you're doing with it. If it doesn't make sense to you and it makes more sense to go step by step and do each fraction separately, then do that. Whatever you think is best, but I'm just giving you both options so you have a choice of what you want to do.